Welcome to wastedevelopers.io. Greetings, and today we will be looking into a question. What is it like to be a programmer? Many engineers who are studying their undergraduation and they want to be programmers, they don't know where to start with. We directly start teaching them different programming languages, operating system background, system design and architecture, software engineering. But what makes a programmer a programmer? How does he think? How does he think any different from regular you? Not just the undergraduate students, but also people who have been into other field and they want to come into computer science and to make a living, they struggle. They struggle to code. They struggle to understand what is coding all about. In today's world, if you don't know coding, you can't be a programmer. If you don't know coding, you can't be in the software field. So let's uncover this in today's video. Let me ask you a simple question. Does a civil engineer get into the field directly to construct a building? Does a mechanical engineer jump into devising a machine without writing down on his paper first? The answer is no to both of these questions, right? You have to first do the paperwork and then get into the field work. The same applies to computer programming too. You must do the paperwork first and then get into the programming. So what is paperwork here and what is field work here? So you might say, oh, okay, I have my laptop, I have high-end configuration, I have all the editors possible, I have the compilers possible. So what stops me? I can jump and code. You can jump and code in C++, Java, Python, whatnot, Go. You can just write. That's the advantage you get with computers, right? So instantaneous results. You go code it and see the results. Whereas for a civil engineer, he has to first plan it, then get onto the field, then construct it. The construction itself takes months to years, depending on the size of the building, and then he sees the output. But when it comes to your computers, it's jiffy. It's instantaneous. So what paperwork as a programmer you should do before getting onto programming, typing your programming and seeing the results? Many people stumble on it. Right? So you can't directly open your editor, type the program and see if the result is coming out or not. You might pass with one or two, but then later on you cannot be a good programmer. You cannot be an expert programmer. And from the programming level up above the ladder, you can't go ahead without the paperwork. So what is the paperwork? What is it like thinking like a programmer? So now when you take a problem and solve it, right? So you want to take a problem and solve it by computer. You have a question and you want to solve that question using a program. This is what we use the programming for, right? So now let's take with a simple example. You are given with a number and your problem to solve if the given number is even number or odd number. Agree? So such a simple problem, right? So find if a given number is is an even number or odd. Very straightforward, very simple problem to understand, isn't it? Oh, for this I don't need to do any paperwork. I can jump on and program. You may, but just understand what is it going behind, what is happening, what is that you need to do in order to solve this. So now let's look into the stage where what is the problem given to you? It's a number and you need to find if it's an even number or odd number. First of all, how does your brain solve this problem? What is an even number? If it is exactly divisible by 2, that is, if the remainder is 0, then it's an even number. If the remainder is non-zero, then it's an odd number. Right? So how do you put it? How do you put it in an instructions way? How do you direct your computer so that it runs, it solves this problem given any size? Right? So that is one way of solving it. Is it the only way of solving it if it is divisible by 2 exactly divisible by 2, then it's an even number. You might have a different logic, don't you? Like, if given number is ending with a digit that is divisible by 2, that's also even number. And you know, if the ending digit of a number falls under 0, 2, 4, 6, 8, that's also an even number. So you don't need to use the entire number to find if the given number is even number or not. The last digit of the number is like 0, 2, 4, 6, 8. Oh yes, it's an even number. If it is 1, 3, 5, 7, 9, it's an odd number. That's another way. And you might have another way too. So you can write one single program in different ways. That is, you can try solve one single problem using different logic. So what is your logic? That makes you a programmer unique. When the different aspects into programming come into picture, it's not just solving the problem, right? And then the later comes, how effectively are you solving? What is the performance of your solution? How speed it can run, and how distributed it can run when you're thrown with a huge amount of data. So there are so many non-functional aspects come into the picture when you're solving. Just to be a programmer, first you need to solve it. So how to solve it? Now, how do you solve it? So you take a number, right? So let's call that number as num, right? And you are given some x here, right? So if the number is divisible by 2, that is, if the remainder is 0, you can print saying that it's even number. Else, right? So if it is not, that is, if number is not divisible by 2, then it's print odd. This, you have to break it down into instructions first before you jump into program. So now you have taken a number. So here let's dry run it with 10. You make a condition. If, right? I said if this number is divisible by 2, then it's an even number. So if is a conditional statement offered by almost every programming language. So if this number is exactly divisible by 2, then you call it, you print it even number. If not, that is else, right? So else if, or you can simply say, if it is not this, then it is automatically this, right? If it's not an even number, it's an odd number. So therefore, either you can write this condition as one more if not, you can simply completely remove it and say else print odd. This is the first step of thinking like a programmer. You understand the problem. What is the problem given to you if number is even or not? And here you can ask, what if the number is not an integer? What if the given number is a float number, is a decimal number? You get the requirements clearly. This is the step one. And let's take another simple problem, simpler than these, I would say. Print from 1 to 10. Okay. So print integers from 1 to 10. You might say, hey, what a silly problem this is. Anybody can say it and anybody can write it. Let's see how complex it is going to be when you are first time programming for such things. Such little things would make you a better programmer. If you can nail it, you can be a good programmer, surely. So what it says, 1 to 10. So I have to start from 1, right? And then go on till 10. Now what is the logic here? What is the logic I can derive? You start with 1, that is given in the problem statement. So you say print 1, right? And then what is next? How do you say print 2? So you add 1 to it, right? So the logic here, what I would want to bring is you add 1, so therefore it becomes the next number in the series. So plus 1, it becomes 2. And plus 1, it becomes 3. Plus 1 becomes 4. You follow it? So you're adding one every time. So you take a starting number, to that number you add one every time. So every time when I say you're iterating, right? You are going one after the other, one after the other until you reach your upper limit. So here lower limit, that is your starting point, is 1, upper limit is 10. So what is your logic? Add 1 repeatedly. So first take 1, print it, add 1 to it, and then print it, add 1 to it, print it. That's the logic. You get it? So think algorithmically or think arithmetically, and then divide it into an instruction. Then translate that into a program. Only then you can succeed. Now, so I would say print 1. So I better take it into variable. Again, number is equal to 1. So I say, and so I have to repeat this process, right? So for repetition, all the programming languages give you iterative constructs, that is loops, while loop, for loop. So you say while this number is less than or equal to 10. So this repeats, this makes sure that this repeats until the number reaches 10. So what I want to say, I want to print 1 first. So print number. Then next time what I do, I add 1 to it, right? So that is num becomes number plus 1. So what has become here? The num has become 2 here, right? So here it was 1 first time, and now the num has become 2. So when you go up again, so when you go up from here, so your num is 2. So 2 is checked against this condition. 2 is less than or equal to 10. Yes, true. So I print 1. So I printed 1 first and then 2, and then num has become 3 next time, right? So 3 is less than, so I print 3. 4, 5, 6, 7, 8, 9, 10. 10 is less than or equal to 10. Yes, print 10. And then 10 becomes 11. Your num becomes 11. That is when 11 is less than or equal to 10. No. So this condition fails. Now this program exits. So you come out of it. Your purpose is solved. What if you are asked to print 1 to 100? You simply change this condition to 100. What if you are asked to print from 100 to 1000? What do you do? So these variations. So your num, the starting point, is 100. Condition goes if num is less than or equal to 1000. So like this, you can take various problems and then first arithmetically solve it on the paper, logically solve it, write it down into instructions, and then dry run it on the paper or whiteboard. When that logic is satisfied, when the logic that you have written satisfies the requirement, the question, you are it. You are a programmer now. You can translate this into any programming language that you want to. So that makes a beginner to become a programmer. First, paperwork, understand the problem, understand the input that is given to you. Is the problem statement clear? Do you have the lower limit and upper limit in the problem? And do you have the logic in your brain? That's what makes you a thinker, right? So you think, how do you solve it? And then step it down. Each step you write the instruction and then solve it. Do you need a conditional statement like if or switch? And do you need iterative statements like while or for loop? Think of it. If you're repeatedly doing something, yes, you need iterative statements. If you're checking a condition, yes, you need a if condition. So then you break it down and write it on the paper. Dry run it, take sample input and try it. If it's solving on paper, then translate that into your favorite programming language. Then you jump onto the field. Then you jump onto the computer and then write it in your editor, build it, compile it, run it. That makes you a programmer. Hope this helped you to become a good programmer. So thank you for watching. For more information, log on to vsdevelopers.io